Hello students, welcome to the second revision lecture of the module 2, and we will be discussing about the examples or the problems on deflection of beams. In the previous lecture, we have seen the formulas required to compute the short term as well as the long term deflections. Now we will be applying those formulas in this lecture to solve the examples. So let's proceed with the examples. I would like to thank Mr. Kiran for sharing the notes which I could directly use for making the presentation. Thank you, Kiran. So now, in this first example, we have a beam of cross section 150 by 300 which is pre-stressed by an parabolic cable. The eccentricity is 75 mm towards the bottom at the midspan, and towards the top at the supports the eccentricity is 25 mm. So the values of E1 and E2 are given here. Then the beam has a span of 8 meters and it has a central point load of 20 kilonewton, means the live load is given as 20 kilonewton, which is in addition to its self weight. Obtain the short term deflection and long term deflection at the midspan if the loss ratio is 0.8 and creep coefficient is 1.6. The given pre-stressing force is 350 kilonewton. So remember here P stands for pre-stressing force, which is 350 kilonewton, and it is not the point load. You won't have this heavy point load on that much of a small cross section beam. So I have seen in the exam valuation that by mistake the given pre-stressing force is taken as a point load, and the deflection values which you get by this silly mistakes go beyond the limit. So be careful. So let us discuss the solution of this example. So let's note down the given data properly. Sections dimensions are 150 by 300. E1, that is the eccentricity of the support, is 25. At the midspan is 75. The live load W is 20 kilonewton at the center. Then we have to compute the self weight, which will be in the form of UDL. Length is given as 8 meters. Pre-stressing force is 350 kilonewton. The loss ratio is equal to 0.8. That means 20% of the pre-stress force we are losing. 0.8 means 80% is the effective pre-stressing force. In some examples, this loss ratio can be given in terms of percentage also. So you need to be careful. You did not worry. If they give 75%, that means your ratio will be 0.75. Then the coefficient of creep is given as 1.6. If not given, you have to assume it as also 1.6 only. Then the value of EC, that is the modulus of elasticity of concrete, we'll consider it as 38 kilonewton per mm square. If not given, you have to assume it as 38 only. So firstly, it's the computation of self weight, which is a very easy step. That is the dimensions into density of concrete. Here we take density of concrete as 24, multiplying by the dimensions, we get a self weight of 1.08 kilonewton per meter. Then the live load given is 20 kilonewton. Let us compute the value of I. As the given section is rectangular, I is given by BD cube by 12. Substituting the values, we get the value of I. Then EC we have considered it as 38 into 10 raised to 3 Newton per mm square. So with this data we need to compute the deflection values. So firstly, let us go for computing the short term deflection, and for that let us find the deflection values due to dead load and live load step by step. So before, if you want, you can write the formula and take, so that it will make your working easy. The short term deflection formula, that is delta is equal to delta DL plus delta LL plus delta P, and we have to find now those individual values. So delta L is the deflection caused due to the dead load, which is in the form of an UDL. So substituting the formula, this formula we have already discussed in the previous lecture. Substituting the values, we get a deflection of 4.49 mm. This will be the downward deflection. Then delta LL, WL into L cube by 48 EI. Substituting the values, we get a live load deflection of 16.63 mm, which is again in the downward direction. Now let us compute the deflection due to the pre-stress force, substituting the values in the formula. Now be careful in substituting E1 and E2 values. Your answer has to be negative here, because pre-stressing force is that force which opposes deflection. So E1 is 25, E2 is 75. We substitute and get the answer as minus 12.73. So we have got the deflection due to the dead load, deflection due to the live load, and deflection due to the pre-stressing force. Now the short term deflection formula goes like this: delta is equal to delta dl plus delta ll plus delta p. So let us substitute all the values and we get the total short term deflection as 8.39 mm. Okay, so the sums are straightforward, and these type of sums only will come in the final exam. So if you practice these sums properly, scoring is damn easy. Now let us next compute the long term deflection. So the formula for long term deflection is delta L, that is delta dl plus delta ll, that is deflection caused due to the dead load and live load, plus delta p into bracket the loss ratio, which is already given as 0.8 in this example, multiplied by 1 plus 5. So substituting the values, we get deflection for long term. Now again I am repeating, you use either this symbol or the triangle symbol, it doesn't matter. See that your answers are correct. So we have found out here both short term as well as long term deflection. So now as the deflection we have got it as positive value, that means it is a downward deflection. So let us check with the permissible limit. Delta should be less than span by 250. So span by 250 gives us a value of 32 mm, whereas we are getting a deflection of 28.43 mm. Hence our deflection is within the limit, hence okay. So this straightforward example comes for 8 marks, where firstly you have to note down the given data properly, use the short term deflection formula, find the short term deflection, use the long term deflection formula and obtain the long term deflection value, and the long term deflection value needs to be checked with the permissible deflection. So hopefully this example is clear. And guys, now this is a revision session, so we cannot go in depth on each example. This is also name is given as fast track revision. Hopefully you have followed the initial videos, that will make these things easy. If you have not seen the initial videos, then God bless you. Now let us discuss the second example for this lecture. Now the variation which I have taken in this example is, I have taken 3 point loads of 7 kilonewton each, spaced at 2 meter equally on the beam. Now this was an homework example during the regular series of lectures. So given given data I have written directly, that is B into D is 250 by 450, E1 is 25, E2 is 65. Now you can relate what is E1, E2, length is 8 meters, then A is 2 meters, that is A is the spacing between the point loads. Then the applied pre-stressing force is 450 kilonewton. The loss ratio is 0.85, phi value is 1.6, and EC has to be taken as 38 kilonewton per mm square. So now the change in this will be while analyzing the deflection due to live load, because here we have the point loads. One point load is at a center, but other 2 point loads are not at the center. Now this thing needs to be considered in this example, and such examples have been asked in your question paper. So computation of self weight is easy, that is the dimensions into density of plain concrete, which is 24. We get the self weight as 2.7 Newton per mm, 2.7 kilonewton per meter. Next we get the live load, which is 7 kilonewton in the form of point load. EC is given, I value is nothing but BD cube by 12. Then let us go for obtaining the deflection. Now dead load deflection is straightforward, which is in the form of a UDL 5 WDL raised to 4 divided by 384 EI. Substitute the values, we get a dead load deflection as 1.99 mm or say 2 mm. Now when we take the point loads, there are two point loads which needs to be considered. One is at the center and other one will be either to the left or the right, because the cable profile when we check at the left side and the right side from the central will be symmetrical. So deflection values on the left side will be central point load with the other point load towards the left, and on the right side will be central point load with the other point load on the right. So don't add it two times. Okay, the point load which is on the left and right of the center has to be taken only once, because either we analyze to the left side of the center or we analyze to the right side of the center. So now for the central point load, the formula is the same which we used in the previous example. Delta live load is equal to WL cube by 48 EI. Now again understand this, we have 3 point loads, one is at the center itself. So the formula remains the same for the central point load. Now in the next step we are considering the point load which is say either to the left of the center or to the right of the center. Any one you have to take and apply the second formula which we have discussed. So delta live load due to a point load which is not at the center is given by WLL into A divided by 24 EI multiplied by 3L square minus 4A square. Now here WLL is the intensity of the point load, A is the spacing between the point loads which is 2 meters written as 2000 mm. Then EI value is substituted as we have computed it initially. So this is the value, that is 7.42 is the deflection due to the point load which is not at the center. So total live load deflection will be addition of both, that is 1.03 plus 1.42, which gives us a total live load deflection of 2.45 mm. Next is to compute deflection due to the pre-stressing force, which will be the resisting force. Substituting the values, we get an deflection due to the pre-stressing force as minus 2.49 mm. Therefore, the total short-term deflection is summation of all the deflections. We get a value of 1.95. Now, important thing again here is live load causes two types of deflection. One is because of the central point load and one is because of the point load which is not at the center but at 2 meters either from left support or from right support. So those two need to be added firstly to get total deflection due to live load. Then next important point is the deflection due to pre-stress will be in the opposite direction, hence automatically we get a minus sign for it. So substituting, we have got the total short term deflection as 1.95 mm. Now again the same step, that is the long term deflection, needs to be repeated. Only the thing is that here we have 3 point loads, so I have taken this example. So to calculate the long term deflection, delta LL is equal to deflection due to the loads, that is dead load and live load, plus delta P into bracket loss ratio multiplied by 1 plus phi. All values we have, nothing to worry, just substitute the values properly and we get a deflection of 6.04 mm, which is very negligible. So when we go for the permissible check, we see that span by 250 gives us a value of 32, whereas the deflection because of the loads is just 6.04. So it is very much safe in serviceability. That one more thing which we understand here is the section is not completely used here. The depth is provided for this case is a bit more than required. That conclusion, which is a technical conclusion not required to be written in the paper, you can draw from this example. So friends, in this class we have revised two examples. One was with a central point load. We computed the dead load, applied the formula for central point load, found out the short term and long term deflection. In the second example, a bit of a variation I have taken, where I have taken more than one point load. One point load is at the center, whereas the other point loads are at the distance of 2 meters from the left support or the right support. Then we have again computed short-term deflection and long-term deflection and checked against the permissible limits. I hope that these two examples are clear, and again I request you all that follow the revision videos as and when they are posted. You have time in your hands, don't waste the time, because when we see the number of views, you are totally A division and B division strength is 125, but we find hardly 35 to 40 people following these videos. Friends, don't take a chance. Please follow the videos then and there. If you have doubts, you are free to text regarding these revision topics. So in the next class, I will come up with few more examples, and then we have to go to the losses in pre-stress, which is also a part of this module. So see you all in the next lecture. Thank you.